standing on the shoulder of giants. That's how mathematics works. You incorporate everyone else's past work, and then you just push it a little bit further. What the intermediate value theorem says is that if we have a continuous function on the interval AB, and n is somewhere in between f of a and f of b, and they're not equal to each other, then there is some number c such that f of c equals n. And when I first learned this, I was really thrown off by the intermediate value theorem until I kind of saw a picture of it. And this is just kind of an example picture to help make some sense of it, not like conclusive proof. All right, so I'm going to mark in A and B right here. And then we have a continuous function from A to B where f of A is not the same as f of B. So f of A is just where our A value ends up at, and f of B is just where our B value ends up at. And the continuous function can look like anything. That's just an example. There shouldn't be any holes in it. There shouldn't be any breaks in it or asymptotes. You should be able to essentially connect a piece of string between A and between B. So what this is saying, it says here that, okay, if you take n, and n is some number in between f of A and f of B. So we'll place it right there. Doesn't really matter where. But if we have a continuous function, since f of A is below n down here, and f of B is above it, and it could be the other way around too, it doesn't really matter. But since we're continuous, that means that we have a path between those 2 points. So if we'd like to get from A to B, then at some point, all the intermediate value theorem is saying is that at some point in between there, you will hit a value, and we can see the value right here. You should hit some value where f of c is equal to n. So the best way to think of that would be to imagine that you're climbing up a mountain. Let's say that the mountain is maybe, 1,000 feet tall. Maybe it's a relatively small mountain. So at the beginning of your climb, you're at the bottom of the mountain, and you're hiking all the way to the top. What the intermediate value theorem says is essentially, at every point of elevation between 0 and 1,000, there will be a point on your journey where you're at that elevation. So for instance, if I took like 725 feet and I said, okay, there is going to be some point where you are at 725 feet. I would mostly agree with that, because to get from 0 to 1,000 feet, I've got to walk the trail up from 0 feet up to an elevation to 1,000. So to get to 1,000, I eventually do have to pass 725 feet. And to help further understand why this works, try and think of the only way that you could get around getting from the ground to the top of the mountain and just skipping over 725 feet. You would have to, number one, teleport yourself. Maybe you get to 700 feet and you just kind of blink or do some Star Trek thing and you're at 775 feet. Well, that's no good for us because that's not continuous. That means that we were passing along our mountain and then we got to a certain point and then just beep, we're up here. Notice we had to lift the pin there a little bit to get up there. So that wouldn't work. Now, could we get to an asymptote? Not really, but even if we got to an asymptote that went up to infinity, we would still cross 725 feet eventually. And then the other thing is, can you get to, right up before 725 feet. Let's say you're at 724 feet elevation. Can you just skip over that 725? Well, no. Even if you jump over the part where the elevation is 725, you're still passing through the elevation 725, maybe not like on the trail itself, but there's really no way to go from 0 to 1,000 and just skip over one of those values. Another metaphor / analogy here would be if you're in a car and you're speeding your car up from 0 to 70 miles per hour. I know that at every point from 0 to 70, there is going to be a moment when your car has every single speed in between 0 and 70. So think how disorienting and, to be honest, fatal it would be if you got your car up to like the Back to the Future thing, you get it up to a certain miles per hour and then just it disappears. So if you were in your car and you get up to 50 and then your car has some special thing that just takes you immediately to 70 miles an hour, the G-forces would kill you because that would be instantaneous acceleration. Your body would pretty much, I think the process is called spaghettification, which is what happens when you just like burst apart at a molecular level. But so if you're going from point A to point B, all the intermediate value theorem establishes is that you have to hit every point in between those. So what do we think? Any really like arguable disagreements, or just we'd like?
So recap it, like if you have points A and B, the intermediate value theorem is just basically saying that between points A and B, that point N has to be, if you were to take any point within that graph, it would hit every single point within.
Yeah, just kind of the other way around. So if you take any value between here and here, intermediate value theorem says that there's got to be some value in between here and here so that when you plug it into your function, you hit that value.
What was the function?
I didn't even give the function. This was just kind of like function in general.
Kind of like if you're going to Carl said 70 miles an hour, you have to go every single miles per hour.
Yeah, there'll be a point where you're going 10 miles an hour, 20, 22, 68, etc. All right, so we've got a couple minutes left, and for those couple minutes, I would like to use those minutes to talk about number 8 on your problem set, which can be a little bit difficult because it doesn't say anywhere in there intermediate value theorem.
There's 2 number 8s.
Oh, there's 2 number 8s? Oh, man. All right. The first number 8. Or, no, there's 3 number 8s? Wow. See, that's the problem that I've had professionally is, like, my math is extremely strong, but when it comes to, like, small details of, like, responding to an email within 2 days or labeling the problems on a problem set correctly, a little bit of a shortcoming. So the second number 8, show that a 0 of the function f of x exists between 1 and 2. Very good thing to notice here, I'm not asking you what that 0 is. I don't care what the 0 is. I'm not asking you to factor a degree 3 polynomial and show me what that 0 is. It might be real, it might be rational, I don't really know. But pay attention to the wording of the question, show that a 0 exists. That is much different than showing something exists than, hey, here's what it is. If it's just existence that you need to show, you're usually going to use the intermediate value theorem. So let's see what we have to do here for this. So we have f of x equals 2x cubed minus 4x squared plus 5x minus 4. And what we'd like to show is that there exists some value that exists between 1 and 2 such that f of that value equals 0. We'll call that value c. Okay. So let's just check a couple things here. What I would like to do is see what is f of 1 and what is f of 2. So f of 1 would be 2 times 1 cubed minus 4 times 1 squared plus 5 times 1 minus 4. So let's see, that would be 2 minus 4 is negative 2, plus 5 is 3, minus 4 is negative 1. And then f of 2, 2 times 2 cubed minus 4 times 2 squared plus 5 times 2 minus 4. All right, 2 cubed is 8, so 16 minus 16, 4 times 4, plus 10 minus 4 puts me at 6. So very interesting here, because that means that f of 1 equal to negative 1 is less than or equal to 0, which is less than or equal to f of 2, which equals 6. And just one last thing to note here, our f of x, that's a polynomial, which is continuous everywhere. So let's check out this intermediate value theorem. If f is a continuous function, okay, it is. It's a polynomial. It is continuous everywhere, so it's definitely continuous from 1 to 2. And n is any number between f of a and f of b. Our a and our b are 1 and 2. So 0 is in between f of 1 and f of 2. So that means that there exists some number c in between 1 and 2 such that f of c equals 0. So our only job to use that theorem is to find the endpoints, and wherever they're looking for you to show that a value exists, if you can just make sure that number 1, you've got a continuous function, and number 2, that the value that you're looking for is in between your endpoints, then just say, by the intermediate value theorem, then yeah, there is a function value c that exists such that f of c equals, our n here is 0. So our interval that we're talking about for that problem would be from 1 to 2. Our n would be 0. We found that f of a equals negative 1 and f of b equals 6. So if you satisfy the if part in a theorem, then you get to use the result. And you get to use the result for free. All you have to show is that what you have satisfies the setup. If it does satisfy the setup, then you get to use the result. All right, y'all should be pretty well set up for the quiz tonight and everything. Good luck with that. Let me know if you have any issues, and otherwise we'll see you tomorrow for lots more problems. Yes, sir?
So we identified that it was a polynomial. It was automatically continuous.
Mm-hmm.
Talking about is for f of 1 and f of 2.
Right.
We got negative 1 and 6. And this question is asking for the 0 specifically.
Yeah.
So it says show that 0. And so we plugged in f of 1 is equal to negative 1, because that's equals to 0. 6, so we show that between the 6 and which is 0.
Right.
So then we come to the conclusion that the function exists.
There is a function value that exists such that f of c equals 0.
Can you just write there is a function value that exists between the points?
Yeah, and just say like by the intermediate value theorem. Just make sure to cite the intermediate value theorem. So just say like, so by the intermediate value theorem, since we met the criteria of it. And if I change that from a 0 to like a 3 or a 2 or any of those values in between negative 1 and 6, you would be all good.